Hi, today I'll be explaining the concepts of stoichiometry. Stoichiometry is used for determining the amount of products formed or reactants used in a chemical reaction through a quantitative lens. In this video, we'll be doing 3 practice problems on stoichiometry. And in order to do the problems with me, you will require a periodic table along with a calculator. So let's get started. So problem 1. So how much carbon dioxide will be produced from 0.5 grams of methane reacting with excess oxygen. So when you have a hydrocarbon, such as methane, reacting with oxygen, it's a combustion reaction. And a combustion reaction always gives out carbon dioxide and water. So let's create the chemical equation. So it'll be CH4 plus O2 makes CO2 and H2O. You then have to balance these equations. So you just look and then balance by looking. So you have 1 carbon on both sides. You have 4 hydrogens on the reactant side and 2 hydrogens on the product side. So you have to make the coefficient a 2 for water. So then you have to see how much water there is on the product side, which is 1, 2, 3, 4. Reactant side has 2 waters, so you have to put the coefficient over here as 2. So it'll be CH4 plus 2O2 makes CO2 and 2H2O. Now, what you have to do is you have to see how much grams of methane is used to come in order to produce carbon dioxide, which you want to find. So you have to basically use the CH4, the amount of CH4 to convert to CO2. So let's do that. So 0.5 grams of CH4, and then you have to convert grams to moles. So 1 mole of CH4 is 16 grams of CH4. This you'll require a periodic table for, so 16 grams CH4 equals 1 mole CH4. And then you have to then convert the 1 mole of CH4 to 1 mole of CO2. After converting to 1 mole of CO2, you have to then get that to grams of CO2 unless they're asking for moles. And if they ask for moles, you're done. So 1 mole of CO2 makes 44 grams CO2. You then just plug this into a calculator, and I'll do that right now. So 0.5 grams divided by 16 equals 0.03125 times 44 equals 1.375 grams CO2. And this is like a basic problem of stoichiometry, but it's fundamental in order to get to the higher level stuff. So let's go on to the next problem. Problem 2. Okay. So let's do a different color, red. Okay. So for problem 2, how much carbon dioxide is obtained by heating 1.31 grams of calcium carbonate? So for this one, calcium is Ca2 plus, and carbonate is CO3 2 minus. So it'll be CaCO3. And when it says that the reaction is being heated, it decomposes. So this is like a decomposition reaction. So calcium carbonate always makes CO2, which is already shown as one of the products, and CaO. And we don't have to balance this. So now what we have to do is we have to convert from CaCO3 to CO2. So you just use the same principles as we tried in the last problem. So how much grams of CaCO3? It's this much. So 1.31 grams CaCO3 times. So how much moles of CaCO3 is, how much grams of CaCO3 is 1 mole? That's 40 plus 12 plus 48. So 52 plus 48 is, I think it's 100. Yeah, 100. So yeah, it's 100 grams Ca equals 1 mole. And it's good to do all the steps in case you make a mistake so you can retrace your work. So then now you have to convert from CaCO3 to CO2. So CaCO3, 1 mole CaCO3 equals 1 CO2 mole times. So 1 mole CO2 makes 44 grams CO2. Then you just calculate in order to find the carbon dioxide. So let's do that. So 1.31 divided by 100 is 0.0131, and then multiply that by 44, and you get 0. And so the amount of sig figs is 3, so you get 0.576. And this is the amount of CO2 obtained. Now let's do one final problem. And yeah. So problem 3. 1 second, pulling up the. So what is the number of moles along with the mass of water formed by the combustion of 2.5 kilograms of acetylene, C2H2, in an excess of oxygen? So this is another combustion reaction. So we have to do 2 things before we get started. First, we have to create the balanced chemical equation like we did last time. So we have C2H2 plus some number of O2 makes CO2 and H2O. So then we have to balance by looking. So we have 2 carbon molecules, so we have to make it 2 CO2. Then we have 2 hydrogens, so we don't have to balance that. Then we have to just look at the oxygen. So I have 4. So we have 4 oxygen plus, 5 oxygen on the product side and 2 oxygen on the reactant side. So this makes it a 5/2. Then what you have to do is you just have to multiply both sides by 2, so you get 2 C2 plus 5O2 makes 4CO2 and 2H2O. Now, after you do this, you have to also convert from kilograms to grams. So 1 kilogram is 1,000 grams. So then you have to do 2.5 kilograms times 1 kilogram, sorry, over 1,000 grams equals, so 2.5 times 1,000 is 2,500. 2,500 grams. So if you have 2,500 grams acetylene, so you have to find how much moles and the mass of water that was formed. So let's get started. So 2,500 grams C2H2 times. So that's so how much grams of C2H2 makes 1 mole of C2H2? So hydrogen is 1 gram, so you have 2 grams of hydrogen and 24 grams of carbon, so 26 grams C2H2 makes 1 mole of C2. It gets repetitive at times, honestly, so. And they have to convert the C2H2 to CO2. I mean, sorry, H2O. So since it's 2 moles of C2H2 makes 2 moles of H2O, you could just do 1 mole C2H2 makes 1 mole H2O. And then you could then calculate to find the amount of moles of H2O formed, which is 2,500 divided by 26. So that's so the amount of sig figs is 2, so it's just 96 moles. So this is part A. So 96 moles of H2O. And then you have to go one step further. So I'll just continue this whole thing. And then 96 moles. So it'll go all the way over here. So 1 mole H2O. And then so you finally have to do 1 mole H2O makes 18 grams. And that will be 96 times 18, which will just be 1730. Or if you want to account for sig figs, you could account for sig figs, but I'll not be for this one, so it'll be 1730.8 grams. So 0.8 grams H2O. And as it's 1730.8 grams, that will be 1.7 kilograms. Yeah, so I guess that's it. So 1 second. So thank you very much. Thank you to OpenStax for providing the book problems. I will link some more down below the in the link section. And thank you so much and stay safe.